So my name is Alfredo Alvarez. I'm going to be talking about procedurally generated design and algorithms. This is basically a collection of algorithms that is used to create new items. So we're going to see that we're going to use it in two contexts. I'm going to explain what places we can use it. So for our agenda, we're first going to talk about what it is and where it's used. We're going to give some cases and some demos. Some of them are going to be really, really simple, just to get the idea through. And then I'm going to talk about how I use it at work. We're going to talk about how it impacts the design process if you take these methodologies. And then at the end, we're going to do a little contrast with a normal design process and how this changes it. All right. So what's procedural generation, content generation? It's basically a technique of algorithms that take parameters, and every time you run them, they give you a different result. So most of the time in program, you expect your functions to give you the same output. If you introduce randomness into them, you get different results every single time. They're really useful to create content, especially used in video games, movies, right now for 3D printing, which we're going to talk about in a little bit. And basically the idea is that you get different permutations for a useful object without having to do any extra manual work. So you pass your troubles designing the function or the system instead of designing multiple copies of the same thing. So let's say, for example, just for a really simple example, you have a video and you need to show 3 different cars. You can define the parts that make a car, just randomly swap them, and get different cars by having, I don't know, let's say some 6 different type of rims, or just different types of chassis or whatever. So that's basically the general idea. Okay, so applications. As we can see on video, you can use them to make people. Have a lot of people that look kind of the same, but they are all different. 3D models. Over here on the right, this is Openscad, which is what I'm going to be using for my examples. Openscad is a free program, that it's a functional program that you can basically write code to generate models for 3D printing, or actually for any type of model they need it. On the left corner, you get images, and that's basically processing. That was a flower made in processing. Every time you run it, you get a different type of flower. So if you were, I don't know, something trivial as a background, or you can use it for something else, like make an animation by making different ones and just swapping them. And then the last one, and the one that is a little bit more recent, it's books. So using some modern procedural techniques, you can actually write full books just by taking the input from, say, Wikipedia and doing what's called generate and test. You generate different books, see what people see the output, and then generate again. So is this new? No, this actually started in the 80s. Why is it important now? The reason it's come once again, and people are paying attention to it, is because computing power has grown in the last 30 years a lot. So it's really easy for a hobbyist or a person that just a layman to get a lot of computers and be able to run their own simulations and their own basically end up with a product. The other thing, it's 3D printing has become also a part of hobbyists. Anyone can do it at home. You can buy a 3D printer. The cheapest ones are $300 or so that actually work. There's some cheaper than that, but they don't actually work. So you can use this to get variations on your products and be able to ship multiple, let's say, for example, you're doing jewelry. You can design an algorithm that will give you different rings. We're going to see a really simple sample of how to make a pendant in a few minutes. And then the last thing is virtual reality is coming in, and they need to fill really, really vast worlds with a lot of content. And this technique has come back into the front because they're being used to fill in the backgrounds and that kind of stuff. Okay. So I'm just going to start directly talking about the different algorithms. So the simplest one that you have is just randomness. It's completely uncontrolled randomness. You just use a code to generate a random number and do a different thing every time you get a different value. This is not very interesting because you really can't control it much, but it's the simplest example that you can get of this. And what you do is you get a random value, and then you get a different iteration, and you go growing on them. On this case, you also get the series that are used, like Fibonacci and that kind of stuff. You can, for example, make the Fibonacci spiral and show it out. It basically will make a spiral that it looks pretty nice. It's aesthetically pleasing, and you can like generate it in different ways and like get different permutations of an object. Okay. So the simplest algorithm you can do if you want to implement is the random walk. It basically, you start in a point. You say, I'm going to move north, left, right, or back, and you just move one step. If you go and trace this, you can end up with a path, and you can put an object in there, let's say a circle or square. In the case, we're going to use a square. And you end up with a graphic of that path that is every time you run it, it's unique by itself. It's a unique iteration. So we're going to use it to make a pendant on the next slide. So if you see on the right here, those are pendants printed from Shapeways. They're coming from plastic on the left, bronze, gold. I don't remember what's in the middle, but then plastic on the right again. They're basically different iterations of the same algorithm. Like I said, this is the most basic algorithm you can run here. It's very squared, I know. It looks like 8-bit kind of thing. But they're basically, so some of these iterations, we ran a few iterations. Some of them don't look very good, like the one on the right. So that was kind of discarded. But then the ones in the middle, the ones that are in solid metals, those were a little bit better, and they were actually pleasing to customers. And I have them on my Shapeways page, but anyways. So if you see on the left, that's what the code for Openscad looks like. And basically, we say how many steps we want to take. In this case, we do 55. We generate from 0 to 4, 55 randoms. We have a function. In this case, I cut the calculation for y, just because we don't need it. And all that does is it tells us if you're going to move up or down. And then at the end, on the bottom here, you basically have the loop that will just run 55 times and get you the path. So this is basically the simplest algorithm you can do. It's called a random walk. As you can see, you can get up with something solid, something actually tangible. This is so right now I'm just doing a little bit of introduction. You can get my email from the slide. If you guys have more questions, I'd love to talk about this. So we can talk more deep. Another very simple algorithm, and it's used a lot in video games. It's maze generation. Basically, all maze generation algorithms are trying to make a bigger path and paths that nobody has to walk. So one path, you can go through one path, and it will start from point A and point B. It has an exit. And then every single other path is just like a random, you don't really need it, but we're putting it there so people can walk and explore. So they're very useful for doing layouts. Like for example, if you're trying to do, if you're an industrial engineer and trying to do a layout for an office, they're fairly you can use generate and test, which is a technique in which you generate a sample field and then try to see which one fits the space that you have. They're useful for that. They're also useful for making patterns for images as a seed for other algorithms. So for example, if you're using processing, you can run a maze generator, generate one image, and then run it through another algorithm to get a random output. 1 second. And last, which is what they originally were made for, video games. So a lot of video games like Diablo 3, for example, they use them a lot, and they generate a lot for very little amounts of money. You can get a lot of content from it. Okay, so the simplest maze that you can do is the binary maze. And I'm going to be really short time on this slide. You basically, all what you do is you decide, you have a cell, 4 walls. For each cell, you decide, am I going to put the left or the left or the top wall? And that's it. It always has a bias. So if you're going to solve the maze, you always have to go straight to the right, and it'll solve it. But it's the simplest because you only need 2 random numbers and you get it. So again, on the left, you have the code in Openscad to do it. This was actually code from an article that I submitted to Make Magazine. It was, I think, in December or something. So basically what you have on top is we define the cell, which is 4 walls, and then a hollow space. And then we just iterate on x and y, how many times we want, and we end up with something like this. So this is an Openscad too, so it's 3D printable again. You can put a hook, make it a pendant. You can make a bunch of them, make it like a chain or whatever. Or just make it a maze for a ball. Okay. So getting to the more complicated ones, generate and test, which is what I was mentioning. So I don't have a visual example of generate and test. There are a lot of people that use generate and test algorithms. They do it using physics simulator to put the constraints. In my case, I'm actually going to explain what I do at work and how do I use this for software instead of like doing graphics. Okay, so I work for GeoRiot. We have two products, BookLinker and Genius Links. I'm going to be talking about Genius Links. Genius Link translates product pages between different stores across countries. Let's say, for example, on Amazon, you want to buy a shoe. You're buying, let's say, in Egypt. Amazon doesn't have a page that ships in Egypt. He looks for a local store that he can sell to that shoe in Egypt based on the metadata we have. So a big problem we have is that we have different metadata. We have the same amount of rules. We have a fixed amount of rules, but we have the same different metadata from every store. Like every single person basically gives us an XML or a JSON file, and they're all different. Like they have different properties and different elements. So what we do is we look at the rules that we have used for stores before. We create a sample of rules that we can run, that we know, different permutations. We know which ones we can use one with another, and we create a gigantic amount of permutations. After that, we run those permutations, again, a fixed set of tests that one of the people that work in the company has picked. And once we've done that, and it runs and it passes, we know that we're really close to what we actually want to use in production. So we grab that set, we isolate it, and we take it, and somebody makes sure to like test it again manually before we put it in production. But it lets us, so original test set used to take us about a week and a half to create. Using this type of techniques and just like using raw computer power has basically lowered to like we can do this in a day and a half. We have onboarded about 186 stores in like the last 3 months. So it's been a lot of savings using these techniques. Okay. So the last thing I want to talk about is so a normal software design process, you basically write requirements. You go and sit down and make a design. After the design, you go write your software, and you come back and test and do multiple iterations, right? So when you're using procedural generation techniques, you're not really looking for requirements, but you're looking for constraints. So if you're trying to do, I don't know, let's say a ring, you know you need the space for the ring, and then you want to let the algorithm be as free as he can, because he's going to come out, once you have a good algorithm that you're going to use, he's going to come out with possibilities that you haven't even thought about it. Once you get there, you want to like look at the possibility, see if there's one that's a good candidate. Once you have a candidate, that might just be the idea that you want to start and try to get it through a different way. But the idea is that you can get inspiration from it and like shorten down your design path. So you basically try to fix an algorithm to a problem, get the constraints, and get it running. Okay, so last thing, just an idea so you guys keep is that you can solve problems and find inspiration just by finding constraints and doing permutations and using different type of algorithms. There's a lot that are already been defined. There's about 63 procedural generation algorithms. You can make a library and just run all of them, see what you get, and then try to see what your next steps are instead of doing a normal design process. So that's my idea to leave with you guys. And when you're going to get a copy of the presentation, it has all the tools. They're going to give it to you guys. So any questions?